Next example, where we have to modify our y particular guess because of the homogeneous solution for this method of undetermined coefficients problem. Let's take a look. We have y double prime minus 4y prime minus 21y equals 4 e to the 7x. And most of the time you can get away without looking at the homogeneous solution first, but you really should always look at it first. Plus you're probably going to have to find it anyway to finish the problem to get the entire solution. But in this case, the homogeneous solution here is c1 times e to the negative 3x plus c2 times e to the 7x. And so there we have a problem. We have a constant times e to the 7x is a homogeneous solution, and here we have a constant times e to the 7x. So normally we'd guess y particular of x is some undetermined coefficient a times e to the 7x. That's not going to work though. This whole thing is going to cancel because it's a homogeneous solution. So what do? We multiply our guess by x. And miraculously that will work, and we'll keep going. Now if we keep going, we get y particular prime of x. Okay, well that's going to be a, let's do the x one first. So a times 1 times e to the 7x. So that's 1/2 the product rule. And we also have a times x times 7 e to the 7x from the other half of the product rule. And it's always nice to simplify these before you keep going. So let's go ahead and group terms. So everything has an a in it. And there's a constant and there's an x term, and then everything has an e to the 7x in it. And so we have a times 1 times e to the 7x, so there's a 1 here. And here we have a times 7x times e to the 7x, so there's a plus 7x. Alright, so now let's do the final y particular double prime of x. Okay, well that's going to be a times, take the derivative of the x part here, we get 0 plus 7 times e to the 7x, then plus the other half of the product rule, a times 1 plus 7x times e to the, times 7 e to the 7x. Right, the other half of the product rule. And again, it's always nice to simplify that before plugging everything into the ODE. So here we have everything has an a still. There's some constant terms, there's some x terms, and then there's e to the 7x. So here we have 7 times a times e to the 7x. And here we have a 7 times 1 times a times e to the 7x. So in total that's 14. And then we have a 7 times a 7x times a times e to the 7x. So that's a plus 49x. All right, so now for the next part, we plug all three of these into the differential equation, solve for a. So we end up with y particular double prime minus 4y particular prime minus 21y particular. Okay, well that equals a times 14 plus 49x e to the 7x. Okay, minus 4 times a times, 1 plus 7x times e to the 7x. And then we have our minus 21, and this one's just ax e to the 7x. All right, well, let's go ahead and try and combine terms here. So let's get all the constants, and let's get all the x terms. So we get equals, we have a. From the first term, we have a times 14 times e to the 7x. So I'll have 14. And the second one we have minus 4a e to the 7x, so I think just minus 4. And the third term, we don't have any constant terms by themselves. So then, let me fix that 4. Okay, so then this is multiplying e to the 7x. Then we also have the x terms, so a. We've got 49x in the first one. Then we've got minus 4 times 7x, so minus 28x. In the last term, we have minus 21x. All that times e to the 7x. And the cool thing here is this actually all cancels out. All of these terms are from the half of the product rule where we took the derivative of e to the 7x, but didn't take the derivative of the multiplication by x, right, the x that we added. And so this term actually acts a lot, pretty much exactly like the homogeneous solution, the C2 e to the 7x, where we just have an x tagged on everywhere. It's all going to cancel out. That's actually kind of why this works. So 49 minus 28 minus 21, well, that's 0. So we end up with 14 minus 4, that's 10a e to the 7x plus 0ax e to the 7x, which is also a really good thing because we don't have any x e to the 7x terms on the right-hand side to solve for. All we have is 4 e to the 7x. If we had ended up with x e to the 7x terms, we would have had to set a equal to 0 and our guess would have fallen apart. But it didn't because of the magical multiplication by x and because the half of the product rule, where we didn't take the derivative with respect to x, we took on the x term, we just did it on the e to the 7x term. It acted like the homogeneous solution completely canceled itself out. So now we have 10a is equal to 4. Well, that means a is equal to 2/5. So our y particular solution is just 2/5 x e to the 7x. And that's it, we're done. If you want the entire solution, you have to add on the homogeneous solution to the particular solution, but we're done finding out the particular solution.